I'm going to talk about the law of conservation of mass with you. Now, I do not have the handout that you guys have in your in that I've posted for you guys to read through, which is fine. I don't need it. I have the general idea of what I want to say. So, the law of conservation of mass. So, I'm just trying to see if I can pull it up in the textbooks here. So this isn't what you guys have, but it's the same idea. This is what really all you need to know is the law of conservation of mass states that in a chemical reaction, the mass of the products always equals the mass of the reactants. Okay? So what this means is that the mass cannot change. All atoms, so the different elements, they must be accounted for. Okay? You cannot lose any, right? So this is going to get into the big picture, which was what we're going to do the next Monday we're together. But I want you to be able to understand it in a different text. So on your note, you have it. You have an example. You have two examples there that show you. So example one is 5 grams of chemical A. You know what? I'll write this out. So at the bottom of this sheet, you have to do these questions in the textbook. There's only 5 questions that you have to do. But your examples are, you have chemical A is 5 grams, all right? And it reacts with chemical B, which is 7 grams. And then it produces chemical C, right? So that's your A plus B. This is the chemical reaction we talked about today, equals C. Okay, so you have 5 grams plus 7 grams equals how many grams? Well, you just add those two together and it'll be 12 grams, right? That's it. That's the concept we want you to take away from this. Now, I'm going to give you another question, and this question is actually one that was on the chemistry unit test, okay? And I'd like you to try to do this one question right now. Don't worry about the lab sheet that's on top of it. That was a law of conservation of mass lab that we can't do. But I want you to do the question here. So you have 0.451 grams of sodium azide used to deploy airbags. Decompose explosively to produce 0.202 grams of solid sodium and nitrogen gas. You must show your work to justify your answer, and it's 3 marks, okay? You don't need to know the compound. It is that one, though. But now you have to show your work and then give me an answer. So what I'd like you to do is I'd like you to pause right now, okay, or write this down, all right? Write this example down, pause it, my video, and then try to figure out the answer, and then press play when you're ready, and then see if you did it right, okay? So you go and do that. All right, hopefully you pause and you try to take up the question, okay? So you have the question here, so we're going to write it out. So it's sodium azide, and it was 0.451 grams, right? And it decomposed, which means it broke down. So it would have been, for your chemical reaction, we started with this, and it decomposed into sodium, and it said nitrogen gas, right? So that was what we would end up with, okay? It told us that we had sodium was 0.202 grams, okay? So we know what this is, 0.451 grams. We know what this is. Now we need to know what this is, okay? So, how do you go about doing this? Well, what you do is you're going to take the total here, right? And you're going to take your total here. 1 grams. And you're going to subtract your units, 2 grams. And then whatever you're left over with is going to be your nitrogen gas, right? Hopefully you were able to figure that out. So you subtracted 0.20. And then you're left with 0.249 grams. Okay, so what this is trying to show you is that no matter what happens in a chemical reaction, whatever the mass you start with, you have to end with. Okay? You cannot destroy atoms and you cannot create new ones. All right? We would have done a lab in class where you would have done 3 little labs, and one of the labs would have shown you losing mass, but that was because it was released as gas. So it was released into the air. You didn't see it, and so all of a sudden your mass is less. Another one would have shown you that the mass got more, but that was because it was using oxygen from the air. And it was pulling the oxygen in that added to the mass. But again, the oxygen was there before. But what it wants to show you is you cannot create anything new, okay? And you cannot destroy any atoms. So whatever you start with, you have to finish with. And that's the concept I want you guys to take away, okay? That's the big one. I have one more question here. Do I want to do it? Yeah, let's do it, because why not? Right, why not? Let's do it. It's another question from the test, okay? Here. Let's just do it to make sure you guys understand. So, students in a science lab performed 2 reactions to investigate the law of conservation of mass, or matter, mass. In reaction 1, the students burned 18.2 grams of propane gas with 6.5 grams of oxygen gas in an open container. That means that there was no lid on it, so that if there was any gas produced, it would have left the container. Okay, that's what that means. If 12.7 grams of water was produced, calculate how much carbon dioxide was created during the reaction. Okay, so write down the information here, and then you guys figure out the answer, and then I will take it up. Okay, so pause, write down the givens here. So you have propane gas, 18.2 grams, plus 6.5 grams of oxygen gas equals, or results in, so the arrow, 12.7 grams of water, and then how much carbon dioxide. Okay, so go ahead, write that down, pause it, figure it out, and then check your answer. Okay, I'm going to take this one up, okay? Or my little notebook here. Yeah, we'll do it here. Okay. All right. So, what do we start with? We started with 18.2 grams propane gas, 6.5 grams oxygen gas, open container, 12.7 grams water. We're looking for how much carbon dioxide. Okay. All right, so it would look like this. Propane gas plus oxygen gas results in water plus carbon, I've combined the words here, carbon dioxide, okay? So that's 18.2 grams plus 6.5 grams must equal 12.7 grams plus what? Okay? So, easy peasy, what do we got to do? Put it on my calculator. You're going to add these two together, 18.2 plus 6.5, and you have 24.7 grams on this side. Well, it also has to equal 24.7 grams on the other side. So now we have to take away your 12.7. Did I write that down right? Yeah. And it will be 12. This will be 12. Okay? So it should equal 12.47 here. So your carbon dioxide equals 12 grams. Hopefully that's what you guys got too. Okay? I think that's enough of the law of conservation of mass. So that's it. I just want to make sure that you understand that. Now on your handout that I posted on under content of law of conservation of mass, there's 5 questions that you have to answer from the textbook. Very short questions. Probably too easy for you guys. But just to keep understanding that, you know, what's on one side of a chemical reaction is on the other. Okay? That's what I want you to take away from this. Okay, that's it.